Good morning, 7th and 8th class children. I already learned about the properties of natural numbers and whole numbers. Here I have explained for you the properties of integers and rational numbers. So I have already know about the properties, so I have to explain. They are exist in addition. These properties of integers and rational numbers are exist in addition, subtractions, multiplications and divisions. Example, you have the first one. You already know the first property is closure property. So closure property in integers, in additions it exists for integers. In subtraction also it exists for integers. In multiplication also it exists for integers. In divisions it is not exist for integers. Okay, closure property exists in for integers. We have to compare for integers. For integers, closure property exists in addition. So I had to write S here. Next one, the closure property of integers exists in subtraction. And next one is the closure property of integers exists in multiplications also. But the closure property of integers is not exist in divisions. Why it is? Because I have given you examples for you here. That is, if A is equal to 1 and B is equal to 2. I have to take two numbers. Any two numbers, I have to take 1 or minus 1. Okay. 1 plus minus 1, that is equal to 0. 0 is also a integer. 1 is an integer and minus 1 is an integer. If the addition of plus 1 and minus 1 is equal to 0 is also an integer. So the closure property exists in additions for integers. Okay. I have to write for in subtraction. I have to write 1 minus 1 here. 1 minus into minus plus 1 plus 1 is equal to 2. Here 1 is an integer, minus 1 also is an integer. The one subtraction of 1 and minus 1, that means 1 plus 1 is equal to 2 is also an integer. So closure property exists in subtraction for integers. Okay. Next one is multiplications. The same thing you have to write here. I have to take 1 and minus 1 are two integers. Then the multiplication of 1 into minus 1 is equal to minus 1 is also an integer. So the closure property are exists in multiplication for integers. But in subtraction, in divisions, 1 divided by minus 1, that is equal to, I have to write another number, 2 divided by 3. 2 is an integer, 3 is an integer. 2 divided by means 2 by 3. 2 by 3 is not an integer, 2 by 3 is a rational number. 2 by 3 is a rational number. So the closure property does not exist in divisions for integers. Okay. If you write 2 is an integer and 3 is an integer, 2 divided by 3, 2 by 3 is not an integer. Because in integers there are plus values, minus values and 0 is there. There is no fractions in the integers. So here 2 divided by 3 means 2 by 3. It is not integers, it is in rational numbers. So the closure property does not exist in divisions for integers. Okay. Next one is rational numbers. In rational numbers, the closure property exists in additions, subtractions, multiplications and divisions also. I have taken the same examples for you. For this, here 2 by 3 is also a rational number. So here 2 is a rational number, 3 is a rational number, 2 by 3 is also a rational number. So the in divisions, the closure property exists in rational numbers. All of you understand or not? In integers, the closure property exists in addition, subtraction, multiplication, but not exists in divisions. But in rational numbers, it exists in all additions, subtraction, multiplications and divisions. Okay. Next one is commutative property. I have write commutative property for addition is A plus B is equal to B plus A. For subtraction, A minus B is equal to B minus A. For multiplication, A into B is equal to B into A. For division, A divided by is equal to B divided by A. We have to use some numbers for substitute in this formula. So we will get the properties in integers. Commutative property exists in additions and does not exist in subtractions, but exists in multiplication, does not exist in divisions. Okay. For integers, the commutative property exists in additions and multiplications only. It does not exist in subtractions and divisions. And I have to observe for rational numbers also. Rational numbers also, the commutative property exists in additions and multiplications, but not exist in subtractions and divisions. Okay. Next one is associative property. So what are the formulas for associative property? I have written here at, for addition, subtraction, multiplication, division. A plus B plus C. You have to given bracket for B plus C here. Here you have to given a bracket for A plus B. So the values of A plus in bracket B plus C equal to bracket of A plus B plus C, both are equal, then the property will be exist. Okay. Next one is A minus B minus C equal to bracket for A minus B minus C. Here A into bracket for B into C is equal to bracket for A into B into C. Here A divided by B, bracket B divided by C, and is equal to bracket A divided by B divided by C. I have to check and substitute some numbers in this formulas. You get the answers is in associative property is existing additions for integers and for additions and multiplications for integers. So I have to observe that associative property exists in additions and multiplications for integers. It does not exist in subtractions and divisions. I have to check for rational numbers associative property. Associative property exists in additions and multiplication, does not exist in subtractions and divisions. Okay. Distributive property. Here distributive property now multiplication over addition. Here there is no addition, subtraction, multiplication, division. Here only the multiplication over the here it is an addition over multiplication or multiplication over addition. I have given some formulas here for you. A into B plus C is equal to A into B plus A into C. This is distributive property. A into here you have to distribute A into for B and A into for C. A into B plus A into C. This is called a distributive property. Here this is also used for the symbol minus also. A into B minus C is equal to A into B minus A into C. We have to use some numbers, some rational numbers or some integers. Take some integers and rational numbers. I have to check this distributive property.